This is the conductance catheter experiment. We have here a current supply. It supplies 50 microamps at 1500 hertz, so 1.5 kilohertz. We have a switch here to switch it on, the power on, and this is to actually engage the current source. So both of these switches need to be down to drive the current. The current comes out from this pin here, which has another electrode or wire connected to it, I'll talk about shortly, and is retrieved through this 10th pin here. Connected to those two pins are these wires and a bunch of other wires that I'll tell you about shortly. They go down through this cable, black cable, and they come out in the conductance catheter. This is normally inserted into the body to estimate the volume of chamber in the heart, like the right ventricle. It has one electrode at the tip, that's where the current will be ejected from, or injected into the ventricle, and one electrode up here at the 10th electrode, and it has 8 measurement electrodes down the length in between. So normally that will be put into this the chamber of the heart, and we're trying to use it to estimate little segments, cylindrical segments of the heart. And the heart is not actually a cylinder, so it's got a different cross section as it goes down. So that's why we have these measurement electrodes to try and measure. So we've got 8 measuring electrodes, which gives us 7 different voltage differential voltages. Before we do that, we want to calculate or calibrate what the current actually is. I promise you that it's 50 microamps, but I guarantee you when you do the experiment it won't come out to be exactly 50 microamps. In order to do that, we have this sort of phantom or dummy resistor ladder set up. These resistors are meant to simulate the cylindrical segments of fluid in the ventricle. There are 9 resistors, and you'll use the middle 7, which will represent the 7 differential voltages between the 8 electrodes in the catheter. That's a bit of a mouthful. So, about the apparatus, the setup will be each of these switches. There are actually 12 switches, but only 10 of them are used. Just switch them all across. So you'll switch them over towards this side first of all, the side where the resistors are. You can use the screwdriver, get the lab demonstrator to use a screwdriver to switch them all across. Make sure that the reference wire for the analog digital converter, it's got a little label that says ref on. Make sure that is connected into the terminal block where it's colored black and written ref on there. And that's for the measuring device, which is this it's a National Instruments analog digital converter, and that goes by USB into the PC where we'll sample the data using MATLAB. So let me just take that out of that. Once you've done that first part, each of these resistors is 6.8 ohms, so you can figure out what, if you measure the voltage, you know the resistance, what is the current. You'll get a current value for every resistor, so you can average that across all of the 7 resistors in the middle. So when you finish that, switch off the current, get the demonstrator to come over ideally. This is a little bit delicate, we need to replace this in future years, so be careful. Unscrew the reference cable, that's going to go into the fluid. And switch all of the little switches across. Hopefully the lab demonstrator will do this for you, so you don't have to take responsibility if you break it. All that does is opens the switches for the resistors. Have a look at the lab manual. So now what will happen is the current will be forced to go through the catheter. So we're ready for the fluid part of the experiment. So you'll put it into this model of the ventricle. Try and get it pretty much so the 10th electrode is the same distance from the top, the meniscus, as the bottom, the first electrode, the D electrode is from the bottom. You won't get it perfectly because the catheter is a little bit curved. Try and center it down the radial line as well, and that will do. So then we'll come across to MATLAB. We'll switch on the power and the current. Oh yeah, don't forget, put the reference wire in. This is messy. Let's go on there. Get this centered. The only thing to be careful with the reference wire is make sure that you don't short circuit it to any of the current electrodes. So with the catheter now inside the little cylinder, the model of the ventricle, we can come to MATLAB. There's some code available on Moodle, you'll download it, run the M file. The input will be 2 for 2 seconds, and should recognize the data acquisition device, and it will output a summary of the amplitudes of the signals. A little bit about the signals. On the top is the raw waveforms. They're very, very noisy. It's really low voltages that we're measuring, so you see we're measuring in the millivolts here, so it's a very noisy signal. But on the bottom is a filtered version of that. So you can see all the differential voltages. You've got V2, 3, 3, 4, and so on, up to V8, 9. So they're the voltages between electrodes 2 and 3 on the catheter, all the way down to 8 and 9 on the catheter. And once again, for your benefit, I've estimated the amplitudes of those waveforms, so you can use that to try and estimate. If this is a voltage, you can estimate what the resistance is. You'll know the conductivity of the fluid, so you can estimate the volume of each segment.